What's up? I'm Vin, and I'm going through the June 2024 Algebra 2 Regents, and I'll leave a link to a copy of this test in the description below. Now let's get started. So first, I'm going through the part 1 questions, the multiple choice. There's 24 questions here, and each one is worth 2 credits. Question 1, which expression is equivalent to, and we have this quadratic expression here. So this is not looking like the standard quadratic expressions that we factor. Instead of x squared, we have x plus 3 squared. So if you could just ignore this and factor it as is, then great. Otherwise, if this bothers you, what you could do is you could say something like u equals x plus 3 and make the substitution. So now I'm going to rewrite this as u squared plus 4 times u, and then we have minus 5. And now this looks like a normal quadratic expression, which we could factor nicely. So I'm looking for two numbers that have a sum of positive 4, and I also need the two numbers to have a product of negative 5. So from here, what we could do is just factor this. The two numbers are going to be 5 and negative 1. So I'll have u plus 5 times u minus 1. And I know this is going to be good because 5 plus negative 1 is 4, and 5 times negative 1 is negative 5. And now from here, I'm just going to plug back in for u. So u is equal to x plus 3. So we're going to have x plus 3 plus 5, and we're multiplying by u minus 1. So I'm going to have x plus 3 and then minus 1 at the end. So then from here, I just combine like terms. I'm going to have x, and then I have 3 plus 5 is 8. And then I have, in the next set of parentheses, 3 minus 1 is going to make positive 2. So the factors are going to be x plus 8 times x plus 2. If you could just look at this original expression and say what two numbers add to 4 and multiply to negative 5, and you could go right to this step, then great. But I find that students like to see the substitution here because it makes it look much simpler. Okay, so that's up to you to decide. If you could handle just jumping right here, then do it. Otherwise, make the substitution. But remember, for this Regents, we do get a calculator. So what we could do is we could write in the original expression. So we have x plus 3 squared, and then plus 4 times x plus 3. And then we just tack on minus 5. And what we could do is we could just type in all of the answer choices and see which one matches. So if we type in the correct answer here, the x plus 8 times x plus 2, notice that we could do this question here without doing any actual algebra. Okay, but I would say it's good to know how to do the algebra, especially when you get to the free response. You're going to have to show your work. So we could see here that choice 2 is correct because the two graphs completely overlap. If I go to the table pressing second graph, notice that each of my y values match for all of my x values. So choice 2 is definitely our answer. Question 2, which value to the nearest tenth is an approximate solution for the equation f of x equals g of x if f of x equals 5 over x minus 3 and g of x equals 2 times 1.3 to the x? So a question like this is meant to be done in the calculator. So we could go to the y equals, and first I'm going to write in f of x. Now be careful here. Please don't do something like this. Don't say 5 over x minus 3. This is a very dangerous bear trap. You have to make sure that if you're going to type in a rational function like this, that you either put the denominator in parentheses, so write x minus 3 in parentheses like this, or what you could do is you could press alpha y equals enter, and that's going to pull up a blank fraction, so you could just do 5 over x minus 3. Okay, so just be careful because if you write it with division and you don't put the denominator in parentheses, it's going to give you something different. And now for g of x, we have 2 times, and then in parentheses, we have 1.3. I close the parentheses and I press the up button here to make the exponent, and then we just type our x. So now we press graph, and you could see that the graphs intersect right here in quadrant 1. So if we want to find the solution, we're just going to press second trace number 5 for intersection. And now I just scroll in the neighborhood. I'm going to press the up arrow here to switch to the red. And now I'm going to scroll in the neighborhood of the intersection, and I press enter 3 times. And here's the intersection point that we need. So to the nearest tenth, we're looking for the x value that satisfies this equation. So the x coordinate here is at 3.89, and this goes on, but we're rounding to the nearest tenth. And in the tenths place, we have an 8. To the right is a 9, so we're going to round up to x equals 3.9. And this is going to match up with choice 2. Question 3, which equation is graphed in the diagram below? So for this one, what I'm noticing is that we have either a sine or a cosine curve. And the midline is occurring here at y equals 5. So I'm noticing if I were to draw in a line like this, a horizontal line, you could see that this is occurring at the middle of this sine or cosine curve. So if we have a midline here, at y equals 5, that allows us to eliminate two answer choices, okay? We could eliminate choice 3 and choice 4 because these have a trailing constant of 3. So that would be a midline at y equals 3. So just know that in general, when you have an equation in the form of, let's say, y equals a sine of bx and then plus c, that the constant at the end here, this is the midline. Okay, so this is the midline. The a value here is the amplitude, and that's the distance from the midline to the high or low point. And then the b value here is the frequency. Okay, so this is just all stuff here that we have to recognize. And this is also true if this were cosine. So this is for sine or cosine. So what I'm also noticing here is the remaining answer choices have the same coefficient of -3. And notice that to go from the midline to the high point here, we're going up 1, 2, 3. So this is making sense so far. But now the $1 million question here is, are we going with -3 sine or -3 cosine? Well, for this, we of course can use a calculator, but if I want to practice doing this without a calculator, I just think of the standard sine curve. It looks like this. It starts at 0, 0, it goes up, down, and then back up again. So this is for sine of x. So if I were to have negative sine x, that would just flip this so that it starts with a downswing like this. So that's how I know that it's going to be a sine and not a cosine curve here, just by looking at it. Why isn't it cosine? Well, because cosine starts either at the maximum or the minimum. It doesn't start on the midline like this. So if I was thinking about, let's say, a cosine curve, I just draw that off to the side. A cosine curve, the standard one here starts at 0, 1, it goes down and then back up again. So if I had negative cosine x, it would start at the minimum and it would go up like this. So that's how, without a calculator, I know that it's going to be choice 1. But of course, we do get a calculator, so there's no shame in typing this in and seeing if it matches the graph. So I'm going to type in -3, and then we have sine pi over 3. Now I could just write pi divided by 3 because I'm multiplying by x. But if I want to use alpha y equals enter again, I can to write my pi over 3. So I have second, and I press the up arrow here to get the pi, and then I have my 3. I hit the right arrow to get out, and then I tack on the x. And then we have plus 5. Please make sure that you are in radian mode for this. So go to mode, make sure you're in radians and not degrees, otherwise your graph is not going to show up. And now I press graph, and what I could do is I could look at the domain of the graph here. It's going from 0 to 10, and actually it looks like it's going out, it's counting by ones here, it's going out to about 12. So if I go out to 12 and I go up to 10, let's see what we get. So I'm going to go from here from 0 to 12, and then I'm going to go on the y-axis from 0 to 10 and see if everything matches. I also had a midline at y equals 5, so I'm just going to type that in as well and see that this matches exactly what we're looking at here. Notice that the midline is making contact with the first loop here at the point, where is this? 1, 2, 3, and then up 5. So if I go 1, 2, 3, and up 5, you could see that the points definitely are matching up. If I were to switch this to, let's say, cosine, then this would change everything here. You could see that this is no longer matching the graph. It's starting from the minimum value here and then going up to the midline like this. So that's why you could see the other answer choices are not going to work. And if I typed in these choices here, they would really miss because, once again, these would have midlines at y equals 3. So choice 1 is definitely our answer. Question 4, which point is in quadrant 3 and is a solution to the system below? So this is something we could do by hand, but we do get a calculator, so we could solve this system graphically. So I'm going to type in here x squared and then minus 24. And then the second equation is y equals x minus 12. So now we press graph. And I'm going to press zoom 6 to put the graph back to normal. And we're looking for the quadrant 3 solution. So we're looking for a solution in this quadrant over here. We have 1, 2, 3, 4. So notice we can't see anything. So there's a few ways around this. What we could do is we could just drop the window down. We could drop the y minimum to, let's say, -20. Or notice that the lowest y value is at -33. So maybe I go down to -40 so that I definitely capture all of the y values here. So now I'm going to press graph, and I could clearly see the quadrant 3 solution. So now I just press second trace number 5 for the intersection, and I have to make sure that I go into quadrant 3 like this, and I press enter 3 times, and here's the solution that we need. So the quadrant 3 solution is occurring at -3, -15. So this is going to match up with choice 2. Now, if this method here is troubling you, what you could do is you could always plug in the points to see which ones check out. And if we plugged in choice 2, we have the x and the y here. If I plug into the first equation, I have negative 15 equals x squared. I'm going to put negative 3 squared and then minus 24. And this gives us negative 15 equals 9 minus 24. And this equation here is definitely true. And then if I plug into the second equation, I have negative 15 equals negative 3 for x minus 12. And this equation is also true. So this point satisfies both equations, and this point is in quadrant 3. So choice 2 is definitely our answer. Question 5, for which equations will the value s equals 4 make the statement an identity? So for this one, what we're going to do is we're going to plug in s equals 4 into Roman numeral 1 and 2 into both of these equations. And we're going to see which ones actually makes an equation that is true. So what we're going to have for the first one is 2x minus 3 squared equals, and now we have 4x squared minus, and if I do 3 times s and s is equal to 4, doing 3 times 4 is going to give us 12. So I have minus 12 times x and then plus 9. So first, let's investigate this. And what we could do is we could just expand this. So we could do 2x minus 3 times 2x minus 3. And if I work this out, I have 2x times 2x is 4x squared. Then I have 2x times negative 3 is negative 6x. And then I have negative 3 times 2x is negative 6x. And then I have negative 3 times negative 3 is positive 9. And notice that this does simplify to 4x squared minus 12x plus 9. So this for sure is an identity. So Roman numeral 1 is good, which means that choice 2 is out and choice 4 is out. So now let's investigate Roman numeral 2. So for this one, I'm going to write it over here. We have x minus 2 to the third equals, and then we're going to plug in s equals 4. So we have x minus 2 times x squared plus, and we're replacing s with 4. So we're going to have 4x and then plus s is equal to 4. We get a plus 4 at the end. So now what I'll do is I'm going to factor this quadratic expression here. So we're looking for two numbers that have a sum of 4, and the two numbers also have to have a product of positive 4. And that's going to give us here, once we start factoring, we have x minus 2 to the third equals x minus 2 times, and now we factor. And the two numbers that will have a sum of 4 and a product of 4 are positive 2 and positive 2. And I can see right away here that this does not match up, because the right side we could express as x minus 2 times x plus 2 squared, since we have matching factors here. And that is not going to be equal to x minus 2 to the third for all x. If somehow we had wound up with x squared minus 4x plus 4, so I'll just write that off to the side. If we had x squared minus 4x plus 4, this we could express as x minus 2 times x minus 2. And then we would have 3 factors of x minus 2, making x minus 2 to the third. But that was not the case here. So Roman numeral 2 is not going to be an identity when s is equal to 4. So that means it's only going to be Roman numeral 1, so choice 1 is our answer. Question 6, the number of bacteria in a sample which can be modeled by an exponential regression is shown in the table below. Assuming this trend continues, approximately how many bacteria would be present 8 hours after the observation began? So to generate the exponential regression equation, we're going to go to stats, we're going to press edit, and we're going to enter the values into this table here. So the time since the observation began, we're going to write in L1s. We have 0, 1, and then we have 2, 3.5, and 4. And then we're just going to write in the corresponding y values in the next column here for L2. So I have 40 going next to 0, and then we have 48, we have 57, we have 75, and we have 82. So once we have all of this typed in, now we go to stats, calculate, and exponential regression, I could press up, and that's option 0 on this calculator. So I just press enter all the way through calculate, and here's the values that we need. So I'm just going to use this screenshot here of the values so that we could just type this into the y equals now. So in the y equals, I'm going to write in for A, we have 40 and then 0.0037. So I'll write up to, let's say, 4 decimal places. This will be plenty accurate for us. And now we have in the parentheses for the B value, we have 1 point, and then we have 196. And then I could just write up to, let's say I'll go out to 36 like this. Okay, so I have 19636 because then I get 2 zeros. So this will be enough for us. And now I'm going to press the up arrow and type in the variable x. So now we have the function here. This is our exponential regression function for this table here. And we want to know how many bacteria would be present 8 hours after the observation began. So the number of hours after the observation is referring to the x values here. So I'm just going to press second graph and go to the table. And we can see here, if I scroll down, this is going to give us the number of bacteria. Now, one thing I want to point out, let's say we had to plug in a decimal value. We could always press second window and change the independent from auto to ask. And then what that does is we could go to the table and just type in the value that we want right away. And if I had to write in a decimal, let's say I cared about what was going on at 9.57, I could do that and get values, like I said, for decimal values as well. So that's just a nice little trick. And if you want to turn the calculator back, you could press second window and just switch back to auto, and then the table will go back to normal the way it was. So the one we care about, once again, was at time t equals 8, or I could say x equals 8. This is the value we want. So based on all the answer choices here, we're rounding to the nearest whole number. So we look to the ones place is a 7, to the right is an 8. So we're going to round up to 168, and that tells us that choice 3 is our answer. Question 7, factored completely. This expression is equivalent to, and we have these 4 answer choices. So for this one, I'm going to do factoring by grouping. And when we get to the end, we're going to check our answer with the calculator. So to do factoring by grouping, I'm going to factor in groups of 2. So I'm going to take out the greatest common factor from here, which is x to the third power. And if I divide by x to the third power each of these terms, I'm going to be left with x plus 4. And if I wanted to check my work, I could always distribute the x to the third to see that it brings me back to the previous line. And now I'm going to focus on the last 2 terms. But when we do factoring by grouping, our goal is to have matching factors left in the parentheses. So I'm not going to take out a positive 9x. I'm going to take out a minus 9x. And the reason being here is when we divide each of these terms by minus 9x, if we do minus 9x squared over minus 9x, we're going to have an x left. And when we do minus 36x divided by minus 9x, we're left with a plus 4. And there's the match that I was talking about. So now I'm going to take out the common x plus 4. So we take out x plus 4, and we're left with, in parentheses here, x to the third, and then minus 9x. So it's tempting to just jump right away to choice 3. Choice 3 is a very dangerous bear trap, okay? We have to be careful here. We have to make sure that we are actually factoring completely, which tells you to factor until you can't factor anymore. So usually when they say factor completely, you're going to have more than one step of factoring. So now we look at x to the third minus 9x, and we could take out the greatest common factor, which is x. So in the next line over here, now we're going to have x plus 4, and then we're going to have times x squared minus 9. So you can see when I take out the x, I divide each of these terms by x, and we're left with this. And now here we have a difference of 2 squares. So I'm thinking of this formula here. A squared minus b squared is equal to a plus b times a minus b. So that's the idea I want to use for the rest of this question. So we have x plus 4, and then we have times x, and then we're doing x plus 3 times x minus 3, okay? Since we have a difference of 2 squares here, I'm doing the square root of x squared, and I have x over here, and then plus or minus the square root of 9 is 3. So now this is going to leave us with x plus 4 times x plus 3 times x minus 3. And now they're out of order, but multiplication is commutative, so I could just go looking for the answer. And I could chop off this one because this is not factored completely, and this doesn't match the factors. And it's looking like choice 2, okay? X, so we have x plus 3, x minus 3, and the x plus 4. Choice 2 is definitely our answer. Question 8, the solution set for the equation here is, and then we have these 4 answer choices. So we can do this the long way, or we could just start plugging in the values in the answer choices and see which ones check out. So if I plug in something like, let's say x equals 6, then we're going to have 6 plus 1 is equal to 4 times 6, and then plus 25. And this gives us 24 plus 25 is 49. So the square root of 49 is equal to 6 plus 1, which is 7. This is a true statement, which means 6 is part of our answer. So I could eliminate choices 1 and 4. 1 says that there is no solution, and 4 says that only -4 is a solution here. But now we have to see, is the answer going to be choice 2 or choice 3? So now we investigate what happens when x is equal to -4. And if we plug in, we get -4 plus 1 equals, and then we have the square root of 4 times -4 plus 25. So this gives us negative 3 equals the square root of, and if we have negative 16 plus 25, that gives us 9. So for this one here, I could see that this answer has to be rejected because when we take the square root of a positive number, we are only getting positive values coming out of that. So we can't have the square root of 9 work out to negative 3. This is no good. We would have to reject that answer. So choice 2 is definitely our answer. Now, look, we could do this question algebraically here, but at the end, we're still going to have to plug in the roots to check with the original equation anyway. So if it's multiple choice, you might as well just plug in. But if you were to do this the long way, then you would start by squaring both sides, and then you could solve the resulting quadratic equation that you get. Question 9, if f of x is represented by the graph below, which translation of f of x would have imaginary roots? So for this question, we have to know that for a function to have imaginary roots, it cannot touch the x-axis. So now looking at all the answer choices, if we replace the x in f of x with x plus 5, that's going to send the whole function to the left 5 units. Okay, so this would send the function to the left 5. If we replace the x's with x minus 5, that's going to send the function here to the right 5 units. So let me just clean this up. This sends the original f of x to the right 5. And then for the last two answer choices, adding 5 to the function shifts everything up 5. And then if we just subtract 5 from the whole function, that sends everything down 5. So I want the one that's going to move this in such a way that the entire function misses the x-axis. So the one that would work here would be choice 3, because you could see that if I move this up 5, right now my minimum value here, let's count, is at 1, 2, 3, negative 4 down here. So if I move this up 5 units, that would send us, let's see, we would go up 1. So I'm just going to take this whole thing here. We're going to go up 1, 2, 3, 4, and then up one more would put the minimum value here. This would put the minimum value now at, it looks like here we're at 2, 1. So the minimum value is at 2, 1. So the entire function here misses the x-axis, and this would make it possible for the function now to have imaginary roots. Okay, if we did any other transformation, the graph would still hit the x-axis, and that means it would have real roots. So choice 3 is our answer. Question 10, the solutions to the equation given here are, and then we have these 4 answer choices to choose from. So for this question, I'm going to do this algebraically, and then I'll show how to do this with the calculator. So if we're doing this algebraically, we want to get this quadratic equation in the form ax squared plus bx plus c equals 0. That way we could use the quadratic formula and just do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And to do this, what we're going to do first is subtract 2x on both sides. And then we're also going to add 3 to both sides. Okay, so we're going to do minus 2x on both sides and then plus 3 on both sides. And now we're going to have 3x squared. We have minus 4x minus 2x is minus 6x. And then we have 2 plus 3 is 5. So I tack on plus 5. On the right side, you see how these terms cancel out here, and we're left with 0. So now we're ready to use the quadratic formula. We have a equals 3, we have b equals negative 6, and we have a c value here of 5. So if I plug into the formula, we're going to have x equals negative b. We're going to write negative 6, which will change to positive 6. So I'll just write that right away. So we're going to say 6 plus or minus. And now be careful here. The most common mistake, especially when students use the calculator, is when you plug in negative 6 and square it, you have to write it in parentheses. Okay, because then if you don't write it with parentheses in the calculator is going to keep the solution negative. And then we have minus 4 times a is equal to 3, and the value c here is equal to 5. And we're dividing all of this by 2 times a, so we're doing 2 times 3. And now I'll write that result over here. We have x equals, and we have 6 plus or minus, and now the part inside the radical here we could just do in the calculator, but that's going to give us 36 minus, and let's see what we get here. So 4 times 3 is 12, and 12 times 5 is 60. So if I do 36 minus 60, that's going to give us negative 24. And we're dividing all of this by 2 times 3, which is 6. So now how do we deal with this part? The minus root 24. Oh, I'm sorry, the root minus 24. The minus is on the inside here. Well, for this one, it helps to know that the square root of negative 1 equals I. So something like square root of negative 24, I could write as the square root of negative 1 times the square root of 24, and then this becomes I square root 24 like this. Okay, so I'm just using properties of radicals and this definition here for I to simplify this. So now we're going to have x equals 6 plus or minus. And now this is I times radical 24, but I'm going to call this the square root of 4 times the square root of 6. The reason being is I want to simplify this and write it in simplest radical form. So when I'm doing that, I need to find a perfect square factor of the number that I'm breaking down. So that's why I'm going with 4 and 6, and I'm not doing 12 times 2 or 8 times 3, because those are not perfect squares. And now this is all over 6. So now we have, I'm going to split this up, 6 over 6, plus or minus, and then we have I times the square root of 4 is 2, and then I have the square root of 6 over 6. And now from here, 2 over 6 reduces to a third. So this is going to give us, we're going to have 6 over 6 is 1, plus or minus, and I have radical 6 over 3, and then times I. So doing this by hand, we could see here that our solution is going to be choice 2. But now the long way to do this, we would go back to the main screen and press mode. And I'm going to switch it from real to A plus BI mode. So I'm going to go over here, and this is going to allow us to type in complex numbers. So now I'm going to write in one of the answers. So I'm going to write in 1 plus, and then I have alpha y equals enter, and we have the square root of 6, and then over 3, and then the I for the imaginary I is here on the decimal, but I have to press second and then the decimal. And now I'm going to press enter, and I'm going to store this as the letter A, because I don't want to have to keep rewriting this. That's going to be way too time consuming. So now what I'm going to do is I'm going to type in the left side and the right side with the letter A. And let's see what we get. We have 3 times alpha math is A, and then I square it. And then I'm going to have here minus 4 times alpha math, and then plus 2. And I get this value here. And now I'm going to do it to the right side. So 2 times we have alpha math is going to pull up A, and then minus 3. And notice that we get an exact match here. So this answer here is definitely good. If we had done this and got the wrong answer, then these values here would not match at all. But the real part matches and the imaginary part matches. If I want to check the second solution, then all I have to do here is just scroll up and go up to my plus sign and write in minus. And I could do this and press minus. It would give me a number like this, and I would store this as, let's say, the letter B, which would be alpha apps. And then I could just type in the equation again, but this time I would write in the letter B. But that is also going to match. Choice 2 is definitely our answer. Question 11, a culture of 1,000 bacteria triples every 10 hours. Which expression models the number of bacteria in the sample after t hours? So for a question like this, what we could do is we could start off here by saying at t equals 0, there's 1,000 bacteria. And 10 hours later, the bacteria is going to triple. So if we triple 1,000, that's going to give us 3,000. So what we could do with this information is just say, all right, let's plug in t equals 10 to all of the answer choices and see which one gives us 3,000. Well, if we plug in 10 here, we're going to get 1,000 times e to the 30th power. And this is definitely going to be way more than 3,000. So this one's out. If we plug in t equals 10 here, this is going to be way more than 3,000 as well. So that's how I know this answer is out. This is tripling 10 times, okay? So if we just keep tripling 10, we do it 10 times, that's way more than 3,000. 2 is out. If we plug in 10 here, this is going to give us 1,000 times 3 to the 100th power. So this would triple 1,000 100 times, okay? So this is also going to be way more than 3,000 here. So I'm going to say this is way more than 3,000. So this is out. So just by process of elimination, it has to be choice 4. But let's see why. So here, notice that t is being divided by 10. So if we plug in t is equal to 10, this is going to give us 1,000 times 3 to the 10 divided by 10 is 1. And if we just do 1,000 times 3, we get exactly 3,000. So choice 4 is definitely correct. Question 12, an initial investment of $5,000 in an account earns 3.5% annual interest. Which function correctly represents a recursive model of the investment after n years? So if we're looking for a recursive model, we could eliminate choices 1 and 3 right away, because for a model to be recursive, it needs to have a starting point and it needs to be defined by the terms before. So the a sub n minus 1 piece here means the term before a sub n. So these would count as recursive models. But now, which one is it? Well, to get the correct answer, we need to know this idea as well. The formula a equals p times 1 plus r to the t powers. We could use this simple formula here to find compound interest. And the reason why we could use the simple formula is because the interest is annual interest, which happens once per year. If it was more complicated, then we would have one of these formulas here, the 1 plus r over n to the nt. So this is if it compounds, let's say, quarterly or semi-annually, then we use this more complicated formula. But for this question, we're going with the simple formula. So now I plug in, P is the principal value, that's the initial investment is 5,000. And then we have 1 plus R, and R, if the rate here is 3.5%, that's 3.5 out of 100, and that simplifies in decimal form as, let me just make that neater. So we have, let's see, so we have 3.5 out of 100 is 0.035. So I have 1 plus 0.035 now to the t power. And here this simplifies to 5,000 times 1.035. And now we have this to the t power. So if you think about what this formula means in the context of what we're looking for, this tells us that if, let's say, 5 years goes by, we multiply our initial investment 5,000 by 1.035 5 times. Okay, that's what it means to raise this to the power 5. So to get to the next year, we would just multiply by 1.035. So that's why it's going to be choice 4 here and not choice 2. For choice 2, the problem is that the first year after the initial investment, if I plug in 5,000 and multiply it by 0.035, this would make the initial investment here go to almost zero. If you take 3.5% of 5,000, that basically wipes out the initial investment almost completely here. So that's how I know that this one is definitely no good. The account has to be growing, so it would need to be multiplied by a number bigger than 1. So choice 4 is definitely our answer. Question 13, which expression is equivalent to, and we have this expression here. So for this question, it really helps to know this formula. A to the b over c is equal to the c root of a to the b power. I remember this by saying power over root. Okay, so when you want to go from radical form to rational exponent form, you just have to know that the power goes up and the root goes down. So this is the power and this is the root when we're going from radical form to rational exponent form. So here, what we're going to do is we're just going to expand this now to 2xy squared. And now I'm going to use properties of radicals here that I'm going to break up the cube root of x squared y into the cube root of x squared times the cube root of y. Okay, so I'm just splitting this up here, which we could do because we have a product. This goes all the way back to the Algebra 1 days when you have something like radical AB. You could call this radical A, radical B. Okay, so that's the formula that I'm using here. And now I'm going to use this power over root concept. So we have 2xy squared. And then we're going to have x to the power is 2 and the root is 3. So I have x to the 2/3. And then I have y, the invisible power here is 1. So I have y to the 1 over 3. And now the next exponent rule I'm going to use, I'll write it over here for now, is the a to the b times a to the c is a to the b plus c. So now we're going to have over here 2. And then this is x to the first. So I'm going to multiply it. We're going to have x to the first times x to the 2/3. So I'm going to do x to the 1 plus 2/3. And if I have to, I'll just say 1 plus 2/3 over here is equal to, we have 3 over 3 plus 2 over 3, and that's equal to 5 over 3. Okay, so this is 5 over 3. So I have x to the 5/3 power. And then for my y terms, I'm going to have 2 plus a third. So 2 is the same thing as 6 over 3. And when I add 1 over 3, that's going to give me 7 over 3. Okay, so I'll just make this a little neater. So you have 6 over 3 plus 1 over 3 is 7 over 3. So I get y to the 7/3 power. So now I just scan the answer choices here, and this is going to match up with choice 1. Question 14, which statements must be true about the polynomial function k of x? So for this question, we are going to use the polynomial remainder theorem for Roman numeral 3. So I'm just going to have this here on the side for now. So let's go through the Roman numerals one by one. X minus 3 is a factor of k of x. If this is true, this would tell us that x equals 3 is a root of k of x. Okay, so x equals 3 is a root of k of x. And if x equals 3 is a root of k of x, this would tell us that k of 3 is equal to 0. So this is something here that we have to investigate, and we will investigate this in a moment with the calculator. Now, Roman numeral 2 is definitely true because 2 shows up in every answer choice. But let's see why. K of 0 would tell us to plug in 0 for every x is equal to 9. And that's true because all of these terms here would wipe out and we would be left with 9 at the end. So Roman numeral 2 makes sense. But now for the last one, this is where we're going to apply the polynomial remainder theorem. K of x divided by x plus 2 has a remainder of 5. So let's look at this theorem here. If a polynomial is divided by a linear polynomial x minus a, then the remainder is equal to f of a. So if we apply that here, I'm going to express this as k of x over, and I'm going to write this as x minus 2. So you could see here that it's in that form of x minus a, and our a value here is going to be negative 2. And it's saying here that when we divide, we have a remainder of 5. So applying the theorem, that would tell us that the remainder is equal to the function value at a. So we could say here then that k of negative 2 would be equal to 5. So this is something, though, that we would need to verify in the calculator. Okay, if this is true, then we could check off Roman numeral 3. So I'm just going to type in k of x. We have negative 2 and then x to the third power. And then after this, we have minus 11x squared. And then we have minus 12x. And we have plus 9. And now I'm going to press second graph here to go to the table. And I'm just going to take down the values that we need. So let's see, is k of 3 equal to 0? Well, look at the function value when x is equal to 3. The function value is equal to negative 180. So this one here is not true. So x minus 3 is not a factor of k of x. And now for this one, is k of negative 2 equal to 5? This one is in fact true. Okay, k of negative 2 is equal to 5, which tells us that when we divide k of x by x plus 2, we are going to have a remainder of 5. So choice 3 is our answer. Now, before we move on, I want to see one more way to do this. Let's say I don't want to use the polynomial remainder theorem and I want to actually do the division myself. Well, I would set x plus 2 equal to 0, and this would give us a root of x equals negative 2. And then I would use this value to do synthetic division. So I write my negative 2 on the outside, and then I write my coefficients here on the inside. So I have negative 2x to the third, I have minus 11x squared, I have minus 12x, and then plus 9. And now I'm going to do the division here. So we're going to bring down the minus 2. Minus 2 times minus 2 is positive 4. And 11, I have negative 11 plus 4 is negative 7. And now I do negative 2 times negative 7 is positive 14. And when I add these numbers, negative 12 plus 14 is 2. And then I have negative 2 times 2 is negative 4. And if I do 9 minus 4, I get 5. And this is my remainder. Okay, if I were to do the division here, k of x divided by x plus 2 would give us negative 2x squared minus 7x plus 2, and then plus 5 over the original divisor here is x plus 2. Okay, so we can do this by hand if you prefer to do it this way, but using the polynomial remainder theorem is a very technical way to do this. Question 15, to prepare for lacrosse tryouts, Cole is increasing the amount of time he spends at the gym. This week he is spending 150 minutes there, and he plans to increase this amount by 2% each week. The amount of time in minutes that he plans to spend at the gym t weeks from now is given by the function a of t. In terms of a daily growth rate, the amount of time Cole is planning to spend at the gym can best be modeled by the function, and we have these 4 options here. So for this question, one of the formulas that we have to know is that when we raise a to the b to the c power, we're going to get a to the b times c. And then the next idea is if we're talking about t weeks, we have to know that 1 week is equal to 7 days. So if we're talking about t weeks, that would be 7 times t days. Okay, so this would be 7 times t days. So I'm just writing this in because this is going to help us when we actually have to find our answer at the end. So starting with the function a of t, what we're going to do here is we're going to do something that seems a little bit counterintuitive. We're going to rewrite, let me just make this neater. So we'll just get this piece out of here. We're going to rewrite the t power here in terms of the product of a number and its reciprocal. So we're going to say here that t is equal to 1 over 7 times 7t. And you'll see why I'm doing this in a moment. So we have 150. So I'm just taking the function here, and we have 1.02. And we're going to write this now to the 1 over 7 and then to the 7t power. And the reason why I'm going this way and I'm not going this way, so I'll write the wrong way over here. And of course, there's an answer choice waiting for us if we do it this way. So why not do it this way? Why not say 7 times 1 over 7t? The problem with that is that we are writing this in terms of the daily growth rate. Okay, so in terms of the daily growth rate, we would want to have the units here or the expression for days. And if there are t weeks, then that's 7 times t days. Okay, so that's why we want this to say 7t at the end. So just looking at that, I could see why these answer choices here are no good. I'm just going to chop those out right away. And now it's down to these two. Okay, and why am I doing this? Well, in order to express the power in terms of 7t, I can't just replace the original t here with the 7t like this and say, oh, I hope no one notices that. That would not work. I actually have to do the algebra here to make this work out. So why does this work out? So I'm just going to chop this one over here out. This one here is no good. So why does this work? Well, if we were to multiply 1 over 7 times 7t, which I have written right here, see how the 7 over 7 would cancel and bring us right back. So this is equivalent to the original a of t. And now to simplify this, I have 150 to the base here that we're going to have, we'll get in the calculator, but this is all being raised to the 7t. So on the main screen here, we're going to do 1.02 to the power 1 over 7. Okay, so 1 divided by 7, and this is the decimal that we need. So now we could replace the base here with 1.00283, and out of the remaining answer choices here, this is going to match up with choice 4. Question 16, Mr. Zachary posts review assignments on the Betamath website for his students. On his last test, 49% of his students used Betamath and passed. Overall, 68% of his students used Betamath. Approximately what percentage of Mr. Zachary's students passed, given that they used Betamath? So for this one here, you may need to reread this a few times, but this is conditional probability. So let's pretend for a moment that Mr. Zachary has 100 students in total. And if we look here, they're telling us 49% of his students used Betamath and passed. Okay, the $1 million phrase here is the word and. So that means out of this population, 49% they used beta and they passed. Okay, so I'm just going to abbreviate here like this. So beta and they passed. But then we look at this information, 68% of his students used Betamath. So here we could say 68 students used Betamath. So let me just actually spell this correctly. So B-E-T-A like this. All right, so now we reread the final part of the question. What percentage of Mr. Zachary's students passed given that they used Betamath? Well, if we're just talking about the Betamath population, that's a total of 68 students. Okay, so 68 used Betamath, and how many used Betamath and passed? That's 49 out of 68 here. Okay, so we are restricting the population just to the students who use Betamath, and then we're finding that new percentage. Now, I could already see that 49 is more than half of 68, so just by default, it has to be choice 4. But let's see what we get. 49 divided by 68 gives us this decimal here, and if we multiply by 100, this will turn it into a percent. So we get 72% if we round to the nearest whole number. So for question 16, choice 4 is our answer. Question 17, given sine theta equals 7 over 25 and theta terminates in quadrant 2, what is the value of tangent theta? So for this question here, we should know this information about the quadrants. We should know ASTC, which tells us all students take crack. No, this tells us where the trig functions are positive or negative. So in quadrant 1, all of the trig functions are positive. In quadrant 2, sine theta and its reciprocal are positive. In quadrant 3, tangent theta and its reciprocal are positive. And in quadrant 4, cosine theta and its reciprocal are positive. And what that means is that if we have an angle that ends in, let's say, quadrant 2, then only the sine function at that angle and its reciprocal are going to give us a positive ratio. Okay, so that's where my head goes. And that's why it makes sense here that sine theta is working out to something positive. So that tells us if we're looking for tangent theta and we're in quadrant 2, the answer at the end has to be negative. So I could just chop out choices 3 and 4. So now let's think about how do we use this ratio here? Well, if our angle is terminating, let's say here, and I'm not drawing this necessarily to scale, what I'm going to do is I have my angle theta, and then this is my reference angle. So I'm just going to magnify this a bit like this. So we have our reference angle is over here, and here's a right triangle. So I drop down a right triangle using the XY axis here. I'm putting The terminal side is the hypotenuse, and the x-axis is the other part making the reference angle here. So then what we have is sine theta is 7/25. So now remember this mnemonic here, SOHCAHTOA. So sine is the ratio of the opposite over the hypotenuse. So what I'm going to do is I'm going to label this triangle here opposite of the reference angle. I'm labeling 7. And then the hypotenuse, I'm going to label as 25. Okay, and if you recognize that this is a 7, 24, 25 right triangle, then excellent. Otherwise, what you'll have to do on the side is you'll have to use the Pythagorean theorem. So you'd say something like, let's say I call this side over here A. I'd have to do 7 squared plus A squared is equal to 25 squared. And I'd have to solve for A, but we do the Pythagorean theorem and we are going to get 24. Okay, so I'll just say here that this missing side is going to be 24. So now let's think about what these sides represent. This is the side opposite of the reference angle. This is the side adjacent, and this is the hypotenuse. So if I'm looking for tangent theta, we are in quadrant 2. So this is a quadrant 2 angle. So I could automatically say it's negative, but then I use my reference angle here and take the ratio of the opposite over the adjacent, and I'm doing 7/24. So our correct answer here is choice 1. Question 18, a family-owned grocery store in New Hartford, New York employs 49 people whose ages are approximately normally distributed with a mean of 36 years and a standard deviation of 6.2 years. Ryan has been hired to work at this store. He is 30 years old. How many people who work at this store would you expect to be younger than Ryan? So for this one here, we can just use the calculator for this, but if you want to understand the concept of what's going on, we have a normal curve here like this, so the bell-shaped curve. At the top of the curve here is the mean, so the average here is 36, and the average is 0 standard deviations away from the average because the average is at the average. And then they're telling us the standard deviation is 6.2. So if I did 36 plus 6.2, that would give me 42.2. So this would be 1 standard deviation going forward. If I went backwards 1 standard deviation, if I did minus 6.2, then that would give me 29.8, like this. Okay, so I could go forward another standard deviation, and I could go backwards another standard deviation. But if we're looking at Ryan, Ryan is 30 years old, so he's like right about here. And we want to know what percent or what amount of people at the store would we expect to be younger than Ryan. So we're looking for this percentage here of the bell curve. Now, later on the test, you have to know that plus or minus 2 standard deviations accounts for the middle 95%. So this is obviously going to be less than 95%, but that's what we mean when we're talking about the percent under the curve, like how much of this space is occupied by this set of numbers. So now let's go to second vars and normal CDF. That's option 2 here. And for the lower bound, what we're going to do is we're going to say the youngest person there is 0 years old, which obviously would most likely not happen. But theoretically, let's say there's someone, there's a baby there. It's a grocery store and the baby's just there like, oh, people are happy because they see a baby. Okay. That, once again, wouldn't happen, but theoretically, the youngest somebody could be would be 0 years old. And then the upper would be 30 because we want to talk about the people who we would expect to be younger than Ryan. And now we go here and we write in the average is 36 and the standard deviation goes underneath. That's 6.2. And now we can just press enter here and we're going to press enter again. And this gives us the decimal value here, the fraction of the people, but we have it in decimal form here, that are going to be less than or equal to 30. And if they employ 49 people, we're just going to take that answer and multiply it by 49 and we'll have our answer. So the closest whole number to our answer here is going to be 8. So choice 4 is our answer. Now this decimal value here, if we multiplied it by 100, would tell us that this is roughly 17% if I round to the nearest percent. So that's what we're talking about when we say what percent of the curve is shaded under in this section here. This would be about 17%. The bulk of it is going to be between here, okay? And we're going to have a symmetric value here also to the right here. But this would, once again, give us a solution of 8 people if we take almost 17% of 49. Question 19, for the function d of x equals cube root of x plus 2, the inverse function d inverse of x equals. So for this one, we have to know the technique for finding an inverse function. And what we're going to do is we're going to switch x and y, and then solve for y. Now, just know that in general that we could say y equals d of x. So the function itself, d of x, represents the y. So when I'm switching x and y, I'm really just going to think of this as y equals, and then I'm going to write x equals instead, and then cube root of, instead of x plus 2, we have y plus 2. So now our goal here is to solve for the y value over here. So what we're going to do is we're going to do the opposite operations to get y by itself. So we have this cube root attached. The opposite of taking the cube root is raising something to the power 3. So we're going to cube both sides. The cube root and the power 3 cancel. And now we have x to the third equals y plus 2. And then to solve for y, all we have to do is subtract 2 on both sides. And this is going to give us, we're going to have x to the third minus 2 is equal to y. And this is our inverse function. D inverse of x is equal to x to the third minus 2. And this is going to match up with choice 4. Question 20, given f of x equals, and we have this polynomial function here, and f of 3 equals 0, which values satisfy f of x equals 0? So for this question, if we want, we could just use the calculator. So we could go over to the y equals, and we could type in the function. So we have f of x equals x to the fourth plus x to the third. And then we have, after this power, we have minus 3x squared plus 9x. And then we have minus 108. And I'm going to go over to the table. We press second graph. And notice that when x is equal to 3, we have the function value here is 0. When x is equal to negative 4, we have another 0. So negative 4 and 3 are definitely part of the answer. But what about these potential imaginary roots? Well, for these, we could go back to the main screen. And let's see, we have 3i to the fourth power. So I have 3i in parentheses to the fourth. And then I have, after this, plus, and then I have 3i to the third power. So I'm just going to plug this in here now to the third. And then we have minus 3 times, and in parentheses, we're going to have 3i squared. So I have 3, and then I have I squared like this, and then plus 9 times 3i. I'm going to plug in the parentheses here, and then minus 108. And let's see what we get. So we press enter, and we get 0 plus 0i, which tells us that 3i is in fact a root. So just plugging into the calculator, we could see that choice 3 is our answer. Just know though, I could do something like this. Minus 3i, I could type in, and then I could store this as the letter a. So that way I could just type in the expression here on the right, but instead of x, I'll plug in a. And if I do it this way, this will show me that the other root does in fact check out. So I'll just show this once. So a to the fourth plus a to the third minus 3 times, and not second, we're going to use alpha to get the a button. So minus 3a squared plus 9a, and then minus 108. And notice here, we get another 0 plus 0i. So choice 3 is definitely our answer. But now let's say we want to do this by hand. So if we're told here that f of 3 equals 0, this tells us that x equals 3 is a root. And if x equals 3 is a root, this tells us that x minus 3 is a factor. So I'll do the division over here. We have a root of x equals 3 from the factor x minus 3. And now for this, what I'm going to do is I'm going to write on the inside here the coefficients. So I have 1x to the fourth, 1x to the third, minus 3x squared, and then I have 9x. I put a 9 here, and then minus 108. Just know that I like to use synthetic division anytime one of my roots is an integer. If I have a different situation where I have a rational root, like a fraction, then I use polynomial division. So here I bring down the 1, 3 times 1 is 3, and then 3 plus 1 is 4, 3 times 4 is 12, and then we have 12 minus 3 is 9, 3 times 9 is 27, and this gives us 36, and then 3 times 36 is 108, and we have no remainder. Okay, so what I'm doing here is I'm dividing x to the fourth plus x. Actually, I'll just write it like this. So I have f of x divided by, and I'm dividing by x minus 3. And this is equal to, so the coefficients tell us what we need next. And that's going to give us x to the third plus 4x squared plus 9x plus 36. And now for this one, what I could do with this is I could factor the right side. So this tells us then that the right side, we could factor to, and I'll just go ahead and do this. We're going to do factoring by grouping. So this is if we want to do this by hand. I could take out an x squared, and I'm left with x plus 4. And I could take out a 9, and I'm left with x plus 4. So then from here, what I have on the right side, I have x squared plus 9 times x plus 4. Now, this one here, x plus 4, if I set it equal to 0, is going to give me a single root of x equals negative 4. But this one, this is where the imaginary roots are coming from. If I do x squared plus 9 equals 0, then I subtract 9, and I have x squared equals minus 9. And then I take the square root of both sides. So I'm going to have x equals plus or minus, and then this I could break down as negative 1 times 9 in separate radicals. So then x would equal plus or minus, and I would have the square root of 9 I'm going to write first is 3, and the square root of negative 1 is I. So that's where the plus or minus 3i is coming from. So choice 3 is definitely our answer. Question 21, the profit function p of x is found by subtracting the cost function c of x from the revenue function r of x. Which function below represents the cost function given p of x equals, and we have a polynomial for p of x, and r of x equals this polynomial here. So for this one, let's set up the equation for the profit function. They're telling us that the profit function is found by subtracting the cost function c of x from the revenue function r of x. So that tells us to do r of x minus c of x. Okay, the word, when we hear subtract from, this phrase here is very deceptive. This is telling us to subtract, but we have to make sure that we switch. Okay, so we have to switch the order in which these functions appear. We're not going to do c of x minus r of x. That's a common mistake, and you could bet there's going to be an answer choice waiting for you. So now we could plug in. P of x is negative 15x squared, and I'll write this over here because this is going to take up a lot of space. So we're going to have negative 15x squared, and then we have plus 600x, and then plus 60. And that's p of x. This is equal to r of x is, we have negative 0.4x squared plus 130x, and then plus 1200. And we are subtracting c of x. So if our goal here is to find c of x, that's this piece here, we should move everything else to the other side. So I'm going to do plus 0.4x squared on both sides. And I'm going to write it up so that we're lining up the like terms here. And then we're going to have minus 130x on both sides. So I'm doing minus 130x on both sides. These terms will cancel, and then minus 1200. Okay, so we have this. And then all we're going to have to do from here is just combine the like terms. So I'll just write this result over here. Right now, be careful, we have minus c of x equals. So we have minus c of x equals, and we have negative 15 plus 0.4. That's going to give us negative 14.6. So we have negative 14.6 x squared. And then we have 600 minus 130 is going to give us 470. So we have plus 470x. And then last, we have 60 minus 1200, and that's going to give us minus 1140. But now to find our final answer, we need this to say c of x equals, not minus c of x equals. We could just multiply everything here by negative 1. And this is going to give us c of x equals, and we're just going to change the sign of everything. We're going to have 14.6x squared. Then we'll have minus 470x, and then we'll have plus 1,140. And now we scan the answer choices here, and it's going to be one of the last two, and it's going to be choice 3. See that we have 14.6x squared minus 470x plus 1140. Question 22, what is the remainder when this polynomial is divided by x minus 2? So for this question, we can use the polynomial remainder theorem again, which says that if we're dividing by this factor here, we could just plug in the opposite number, and that will be the remainder. So all we have to do here is just plug in 2, and this will tell us the remainder. After this, I will show how to do this by polynomial division because I didn't go over that technique yet. I've only shown synthetic division so far. But this is the fastest way to get to the answer. So 2 to the third power is 8. 8 times 4 is 32. So I have 32. And then I have minus 6 plus 3. So this gives me 26 plus 3, which is 29. So my remainder would be 29. But if I wanted to show more steps here, do this the longer way, then I would do the polynomial division. So I write the entire polynomial on the inside, 4x to the third. And when I teach this, I show students to put a placeholder there. So we don't have an x squared term, but I'll write 0x squared just in place here so that it makes the math easier later. And then we have minus 3x and then plus 3, and we're dividing by x minus 2. So with this technique, what we do is we divide the leading terms. So I'm doing 4x to the third divided by x is 4x squared. And then I have to distribute. So I have 4x squared times x is 4x to the third. And then I have 4x squared times negative 2 is negative 8x squared. But then this is where most students mess up if they are going to mess up. This you have to subtract. And when you subtract a polynomial, the minus has to distribute. So the fast way of doing this is to just change the sign of everything underneath. So I could say minus this plus this. And now these terms will cancel. 0x squared plus 8x squared is 8x squared. And now I bring down the next term, minus 3x. And I start the process all over. So now I'm going to shift my focus over to this term over here. I'm doing 8x squared divided by x is 8x. So we're dividing by 8x. I distribute, I get 8x squared. And then when I do 8x times minus 2, that's minus 16x. I have to subtract this product. So here, if I'm subtracting a polynomial, it's going to change the sign of everything. These terms cancel. 16x minus 3x is 13x. And now I bring down this plus 3 here, and I do this one more time. I focus now on the new leading term is 13x, and 13x divided by x is 13. So this is my going in the quotient here. 13 times x is 13x, and then 13 times negative 2 is negative 26. But we are subtracting, so this is going to become a minus 13x, and this will become plus 26. These terms cancel, and we're left with a remainder of 29 over our original divisor is x minus 2. But we just want the remainder part here, so the remainder is 29. Choice 4 is definitely correct. Question 23, the parabola with equation given here has, and we have these 4 answer choices. So for a question like this, the first thing that I would do is get this in vertex form. So I'm just going to solve this for y. So I could start by dividing both sides by 12. If I divide both sides by 12, that's going to give us on the left side, we're going to have just y plus 1 equals, and on the right side, instead of saying x minus 4 squared over 12, I'm going to say 1 over 12 and then times x minus 4 squared. Okay, so I'm just clean that up a bit. We're going to have 1 over 12 times x minus 4 squared. And now I could subtract 1 on both sides like this. Okay, so this is going to give us the vertex form here. We're going to have 1 over 12, and then we have x minus 4 squared, and then minus 1. If you don't recognize vertex form, that's when your quadratic is in the form of a times x minus h squared, and then plus k. And this allows us to identify the vertex. The vertex here, just by looking at the equation, is going to be 4, negative 1. Okay, the h, we take the opposite of. Notice that it's x minus h squared. So here, the opposite of minus 4 would be positive 4. And then the k value just directly matches the constant after the square. So this would be our k value in our vertex. So then what I do is I sketch this out. So we're going to have some parabola. The vertex is at 4, negative 1. So that's over here. This is the vertex. And it's a parabola where the coefficient of x squared is positive. So this is a parabola that's going to open upwards. We could just graph this in the calculator, but I think it will help here just to know that if the coefficient of x squared is positive, that the parabola opens upward. So I'm not necessarily drawing this to scale. This is just to help us with the concept of how do we find the focus and directrix. So the focus of a parabola is the point that is inside the parabola. Like I think of the parabola almost as kind of like a bag. The focus would be inside of the bag, and the directrix is outside here like this. And the concept of what a parabola is that a parabola is the set of all points that are equidistant from the focus and the directrix. So no matter where I am on the parabola, the distance from the parabola to the focus has to be equal to the distance to the directrix. So how that's going to help us here is it's going to give us reasonable answer choices to rule out here. So something like the vertex is 4, 2, I could eliminate right away because the vertex is at 4, negative 1. The focus is at 4, negative 1 can't be the case because the focus has to be inside the parabola. So I'm imagining the focus is like somewhere in this space and the directrix is somewhere underneath. So now it's down to these 2 answer choices. And if we had to just guess here, like at least now we have 50% odds. But now, how do we know for sure which answer choice that it is? the key defining detail is going to be this coefficient here, the 1 over 12. What I think of for focused directrix questions is I don't call this A, I call this 1 over 4p. And I'll tell you what this means in the context of the graph. So here, this is the vertex, this is the focus, and this is the directrix. The distance from the focus to the vertex is equal to p, and the distance from the vertex to the directrix is also equal to p. So then what I could do here is I could just match up the terms here. Notice that the a value here, so we're just focusing over here, the a value is 1 over 12. That's what we were calling it formerly, is now the 1 over 4p value. So I just have to set these two values here equal to each other, and that'll tell us what the value p is. So I could just do that over here. 1 over 4p is equal to 1 over 12. And just think about it. The numerators match, so we need the denominators to match. So p would have to be equal to 3. So if we have a p value here equal to 3, now we could just count the boxes and see which of these answer choices it would have to be. So now we could eliminate choice 4 because there are 3 units between the focus and the vertex, not 4. So the answer has to be choice 3, but let's see why. So we have the equation for the directrix is y equals -4. And if we see the p-value here was 3, if we count down 3 units from the y value at the vertex -1, going down 3, if we go -1 minus 3, that brings us to a height of -4. So this equation here would be y equals -4. So choice 3 is definitely our answer. Question 24, Jay is training for a bike race over 15 weeks. At the end of the first week, he has ridden 10 miles and he is planning to increase his weekly distance by 9% each week. Approximately how many miles total will he have ridden from the beginning of his training to the end of the 15th week? So for this one here, we have to just think here. For the first week, we have Jay is going, let's see, he went 10 miles. And then he's increasing by 9%. 9% is equal to 9 over 100. And this as a decimal is 0.09. So if he's increasing his run distance by 9%, then that would be the 10 miles. But now increased by 9% would be this. But then the following week would be 10 and then times 1.09 to the second power. And this would go on. And the actual question here is approximately how many miles will he have ridden from the beginning of his training to the end of the 15th week. So here, this is representing week 1. And then this is over here, week 2. And then so on. So let me just make that neater. So this, I'll just clean that up, is for week 2. And then this is going to go on and on all the way to week 15. So this is a geometric series because notice here that this is the sequence here of terms is increasing by the same common ratio. The common ratio here we could say is 1.09. That is what we are multiplying by to get from one term to the next. However, this is going to be finite. This is going to end at the 15th week. And at the 15th week, this would be 10 times 1.09 to the 14th power. Because if you look here, notice week 1, there is no power of 1.09. Week 2, it's 1.09 to the first. So whatever week we're up to, like over here, we have week 3, the power is always 1 less than the week. So by week 15, 1 less than 15 would be giving us a power of 14. But there's a nice way to do this. We can just type all of this in the calculator if you have the patience, or you could use the great formula, the sum of the first n terms of a geometric series. If you look on the reference page, you could find by doing the first term times 1 minus r to the n power over 1 minus r. So here we have the r value. We're going to have n equals 15 because we're doing 15 weeks. You could think of this as over here, this is our first term. This is a1, this would be a2, and this would be a3, and so on. So we could just plug all of this into the formula. So I'm going to press alpha y equals enter to pull up a blank fraction. A1 is 10, and then we're multiplying by 1 minus r is 1.09, and we're raising r to the power n, and n equals 15. And now we get out of the exponent, we close the parentheses, and in the denominator, we could write 1 minus r is 1.09, and here's the value we need. So we could see here that this sum is going to work out to choice 4. We have 293.609. So now we move on to the part 2 questions. There's 8 questions here, and each one is worth 2 credits. Question 25, given x is a real number, write the expression in simplest a plus bi form. So for this question, we have to know that I squared is equal to -1. So now we're going to expand this here, this product, but we have to keep this part in mind. So we have x times 3 first is 3x, and then we have x times minus 2xi. So we're going to have minus, and when I do x times x, I get x squared. So we're going to have 2x squared I like this. And then next, we're going to distribute the 2i. 2i times 3 is 6i. And then after this, we're going to have 2i times minus 2xi. So 2 times -2 is -4. And then we have x just tagging along. And then I times I is I squared. So here's that piece we're going to have to make use of already for this part. And then we have this trailing 2x squared I at the end that we're just going to add on. Okay, so this part just tacks on. And notice that these are matching opposites. So this term and this term will just cancel out nicely. So now we're going to go to the next line. We have 3x. We have plus 6i. And now this part, we have minus 4x I squared. This piece, we're going to replace with -1. Okay, so that's going to go over here. We're going to have -1, and we're multiplying that by -4x. And then that was the last term because this term here canceled out. So now this is going to work out to, we're going to have 3x plus 6i, and then -4x times -1 is plus 4x. And now we could combine like terms. We're going to do 3x plus 4x is 7x. So we have 7x plus 6i. And here's our answer in a plus bi form. We have the real part here and the imaginary part here. If you mix up the order and say 6i plus 7x, they will still give you full credit, but this is the better way to write your answer. Question 26, solve this equation algebraically for t to the nearest hundredth. Now, I just want to point out that if you solve this using the calculator, you will get half credit. I know they're telling us to do this algebraically, but you can get half credit if you do something other than algebra, which is better than getting a 0. So let's say, though, we do want the full credit, then we are going to do this algebraically. So we could start by dividing both sides by 3.8. And that's going to give us, after 3.8 over 3.8 cancels, we're going to have e to the 1.5t equals, and we have 16 over 3.8. I'm going to type this all in the calculator at the end. So right now, I'm just going to leave it in fraction form. And now to get rid of e, the opposite of e is natural log. So I'm going to take the natural log of both sides. And this is going to give us now on the left side, after natural log and e cancel, 1.5t equals, and we have natural log of 16 over 3.8. And now finally, to solve for t, we're going to divide both sides by 1.5. So divide by 1.5 on the left and the right. And this is going to tell us that t equals, so we're doing natural log of 16 divided by 3.8. I could close the parentheses, and then I divide that by 1.5. Okay, so here is our value of t. If we wanted to do this all in the calculator and just get partial credit, what I would do is write 3.8, e is second natural log, and then the power is 1.5t. And then under it, I'm going to write 16. And I press graph, and I'm like, oh no, I can't see anything. I press zoom 6, and I can't see the intersection. And that's because I have to go up to 16. So I'm going to go above 16 because that's the height we have to reach. So it helps to go a little bit above. And we get this value here. And if I press second trace 5, and I go up to the intersection and press enter 3 times, then notice that I get the same decimal that I had on the main screen. Okay, I'm going to press second mode and then second minus to pull up that answer. And you can see how these decimals match. So you can use the graph. However, if you're, once again, the question's telling you to do this algebraically and you don't, you're going to get half credit. But if you don't know how to do the algebra, it's better to get some credit than none. So we're rounding to the nearest hundredth. We're going to say t equals, and in the hundredths place, we have a 5. To the right is an 8. So we're rounding up to 0.96. And here's our solution to question 26. Question 27, in an attempt to get the student body's opinion of a new dress code, members of the statistics class surveyed the students of the first period computer science class. Explain a statistical bias in the method of data collection. So for this one, the bias is that they're focusing on just the first period computer science class. This is too specific of a class. This is a class of people with STEM interest. I mean, there's a lot of, uncertainty here. We don't know if everyone's mandated to take this class, but generally when you want to reduce bias in a survey, you want to make it as random as possible. And this just does not seem that random. Okay, so in the explanation, we could say the bias is that this is not random enough. The computer science class is only focusing on a specific portion of the student population. So I'll say here, like, this is too specific. Instead, we could survey every fifth student entering the school building for the entire day. So I added in this extra detail here because if we survey every fifth student entering the school building, this is going to capture more of the entire population of the school. Question 28, sketch a graph of polynomial p of x given the criteria below. So we have p of x has zeros only at -5, 1, and 4. The zeros are also known as the roots, and that's where the graph crosses or touches the x-axis. So I'm going to mark off the x-axis here at -5, and I'm going to put a point here at -5, 0, and this represents one of the zeros. And then we have zeros at 1 and 4, so I'm going to count out to 5 in this direction. And at 1, we have a 0, and at 4, we have another 0. So this takes care of the first point. And then as x goes to infinity, that tells you to go all the way to the right. Okay, so as x goes to infinity, we're going all the way to the right. P of x is going to -infinity. Just think of this, y equals p of x, this notation here. So when they tell you where p of x is going, they're telling you where the y or the height of the graph is going. So that's telling you that the graph is dropping down as time goes on. So when I sketch this second bullet point here, as we go all the way to the right, the graph is dropping off to -infinity. So that means that this root at x equals 4, after this point, the graph is going to drop off like this. This is the end behavior. And now for the last bullet point, as x goes to -infinity, the graph is going to -infinity. So that means if we go all the way left, after this last root here, the graph is just going to drop down like this. So now I have to sketch the stuff in between, because if this is a polynomial function, p of x, then that means it's going to be all connected. So here we have to be careful. It might be tempting to do something like this, to just draw it where it's passing through the x-axis each time. But if we did that, then the end behavior going this way would go off to infinity. So that means that at x equals 1, what we could do is we could draw the graph tangent to the x-axis like this, because these are the only roots that are allowed. The key word here, only. We cannot introduce another root. We have to just keep it to 3 roots. So we have a point of tangency at x equals 1. So then the graph could go back up and then come back down and then drop forever. Okay, so this is a potential sketch of the polynomial p of x. Question 29, the height above ground of a Ferris wheel car can be modeled by the function h of t, where h is measured in feet and t is measured in minutes. State the period of the function and describe what the period represents in this context. So over here, I'm just going to draw out a circle. This represents our Ferris wheel. And the Ferris wheel car holding the people, let's say, is this piece over here. Okay, so this is the Ferris wheel car. And what's happening as this thing just keeps rotating around like this is that the height of the car, the value h is the height above ground, is bouncing between two specific values here. The maximum value of h of t is representing the maximum height that the Ferris wheel car will reach, and the minimum value of h of t represents the low point. But you could see here, as this thing rotates, so this piece over here, as it rotates, it's staying between these two heights. So that's why the sine or cosine curve is an appropriate function to model this. So let's think about what is the period of a sine or cosine curve. The period tells you how much time it takes for the sine or cosine curve to complete one full cycle. So what we could say here is the context is that the period will tell us how much time it takes for the Ferris wheel car to make one full rotation. But now, how do we actually find the period? Well, anytime we have a trig function in this form here, so I'm going to write it out like this, y equals, and we have a times cosine, I'll write it as bx, and then plus c. The value a is the amplitude. The value b here is the frequency. And the value c is the midline. Okay, so that's the midline. But now, what is the relationship between the frequency and the period? The period is equal to 2 pi divided by the frequency, okay? And I'll just put the value b here because I use b in this equation here. So when I want to find the period of the function, all I have to do is divide 2 pi by, let me just make that neater, so 2 pi, we're dividing it by the coefficient of the variable. And notice that the coefficient of the variable is 2 pi over 5. So we're dividing this by 2 pi over 5. And now I'm going to use keep change flip. This is 2 pi, and then times, I flip the denominator to 5 over 2 pi. And notice that these units, 2 pi over 2 pi just cancel out. So the period here is equal to 5, and the units for t are minutes. So the period is 5 minutes. So now what does this mean in the context of the situation is that it takes 5 minutes for the Ferris wheel car to make one full rotation. Question 30, we're going to solve algebraically for all values of x. And we have this rational equation here. So for a question like this, we could find the least common denominator between these three fractions. And our denominators are 1, x, and x plus 5. So we have a least common denominator of x times x plus 5. So turning all of these denominators into this is one way we could solve this question. Or what we could do is we could just multiply this whole equation by x times x plus 5. Now, before we get into this, one thing I want to point out is that the original equation, one thing you have to be very careful of is that your x value cannot be something that makes the original equation have a 0 denominator. So notice if x was equal to 0, I would have 3 over 0, which is undefined. So x equals 0 cannot be a solution. And then if I had x equals negative 5, that would make that first fraction have a 0 denominator, which would also be no good. So I'm just going to rule out these two x values to start. So now I'm going to multiply everything by x times x plus 5. And we're going to have 8 times x plus 5. And then over x plus 5. So you see that first fraction inside the brackets. If I multiply by x times x plus 5, it's going up in the numerator. And then we have minus 3 over x. And then this is being multiplied by x times x plus 5. And then after the equal sign, we have 5 times x plus 5. And now we could start to simplify this. So x plus 5 over x plus 5 cancels. X over x cancels. And first we're going to have 8x. And then be very, 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 very careful here. It's very tempting to say this. But saying minus 3x plus 5 is a very dangerous bear trap. Okay, we have to make sure that the parentheses carry down like this, because what we're going to have to do in a moment is distribute the minus 3, which is going to change the signs of both of these terms on the inside. Okay, and now this over here, we can just distribute. We have 5x times x is 5x squared. And then we have 5x times 5 is positive 25x. And now from here, I'll just go ahead and expand this. We have 8x, and then we have minus 3x minus 15 equals, and we have 5x squared plus 25x. So what I'm going to do is get all of the terms on one side. And first I'll simplify this a bit. So 8x minus 3x is 5x. So we have 5x minus 15 equals this. And I'm going to move all of the terms to the right because I already have my positive x squared term on the right. So I'm going to go minus 5x on both sides. And in one step, I'll also do plus 15 on both sides. So that's going to bring us here. These terms cancel out, and we have 0 equals 5x squared. 25x minus 5x is going to give us plus 20x. And then we have plus 15. And now I'm going to write this next result over here. We're going to take out a greatest common factor of 5, and we're left with x squared plus 4x plus 3. And now for this part, this will factor nicely. This is 5 times, we're going to have x plus 3 times x plus 1. Because if I do the sum here, 3 plus 1 is 4, and 3 times 1 is 3. And now don't set 5 equal to 0, because that's just a silly statement to make. But you could set x plus 3 equal to 0, and you could set x plus 1 equal to 0. And then from here, this first equation is going to tell us that x equals negative 3 is a solution. And also this equation is going to tell us x equals negative 1 is a second solution. And remember what I said in the beginning, to see if those values of x would make the denominator 0, but we only had to look out for 0 and -5. These values are fine, so these are definitely our solutions. Question 31, the transportation methods used by the upperclassmen at Calhoun High School are summarized in the table below. Are the events being a junior and driving to school independent? And we have to use statistical evidence to justify our answer. So for this one here, to see if these events are independent, being a junior and driving to school, the strategy I want to go with is see if the probability of being a junior and driving is equal to the probability of being a junior times the probability of driving to school. So now I'm going to go to this table here. And what I like to do for questions like this is find the totals. So if we add this up, if we do 58 plus 81, this is going to give us 139. Okay, and then I move here, this is going to give us 114. And if we add these two, and then 12 plus 12 is going to give us 24. So then if we find the total, this is going to give us 277 after we add these three values up. So now I could do the same thing going this way. If I add across for the first row, 58 plus 75 plus 12 is going to give us 145. And then I do the same thing for this row, 81 plus 39 plus 12. That's going to give us 132. And you could even check if you did 145 plus 132, that's also going to give you 277. So now I'm going to go ahead and carry out this strategy here. So the probability of being a junior and driving to school, well, we just look at this entry over here. So the number of juniors that drive to school is 58. So the probability of being a junior and driving to school is equal to 58 over the total number of people in this survey here, or however they're gathering the data, is 277. Okay, and then I'm going to use the calculator in a moment to see what this decimal works out to. But now let's see, what is the probability of being a junior? So the probability of being a junior, there are, if we look at this row, 145 juniors out of the total number of people here, 277. And then the probability that someone is driving to school, we look at the total amount of people that drive to school between the juniors and seniors, that's 139. And then we're dividing by the total number of people we're talking about here is 277. So now we could just plug these values into the equation, and we're going to use the calculator to get the decimals we need. So we have 58 over 277. So that's our first fraction here, and it gives us this decimal. And now we're multiplying the probability that someone is a junior by the probability that somebody drives to school. So we're going to do the probability of someone being a junior is 145 over 277. And we're multiplying that by the probability that somebody drives to school is 139 over 277. And let's see if these decimals match, and they do not match. So that tells you that these events here are not independent. If you've never seen this notation before, the 3 dots means therefore. So I'm saying here, therefore the events are not independent. Question 32, can f of x be classified as an odd function? And we have to justify our answer. So the easiest way to convince yourself that a function is odd is if you turn the graph upside down and get the same graph, then the function is odd. So think of something like, let's say, x to the 3rd power. If I were to turn this graph upside down, so I'm going to start here with this graph, and I'm just going to flip it upside down. If the graph that I get is the same graph as the original graph, then the original function is odd. So turning the graph upside down does not change what the graph looks like. The problem with the one that they gave us, when they gave us x to the 3rd plus 7, that shifts the graph up 7 units, the x to the 3rd graph. So that would give us something like this. So when I flip this upside down, I'm going to get something that looks like this. Okay, so let me just draw that a little bit neater. So it's going to look something like this. The y-intercept is going to go from 7 down to -7. So the graphs are not going to be the same. So if you wanted to write an explanation, you could say that when I rotate the graph 180 degrees about the origin, the new graph is not the same as the original graph. So that explanation would be fine. If you want to use the textbook definition, you could say here, if f of -x is equal to -f of x, then f of x is odd. So if you could show this equation is true, then you could draw the conclusion that f of x is odd. This way that I'm writing now is more technical. It's definitely a bit more challenging than just saying, oh, when I turn the graph upside down, it doesn't match. This is easier to see, but this might be a harder sentence to write. So it's up to you to decide which way you think is easier. If I go this route though, then I have to find f of negative x, and I do that by replacing the x with negative x in place here. So I'm going to put a minus x here. And now the math that I'm doing in my head to simplify this, when I look at this, negative x to the third is the same thing as negative x times negative x times negative x. And when I do negative x times negative x, I get x squared. And when I multiply by negative x again, now I get negative x to the third because I get a positive times a negative. So this would simplify to negative x to the third and then plus 7. So this is f of negative x. Now, negative f of x would be if I start with this equation here, f of x, which is equal to x to the third plus 7, and I multiply the whole equation here by negative 1. This would give me negative f of x equals, and if I distribute the minus 1 on the right, I get minus x to the third minus 7. So now focus here on f of negative x and negative f of x. Notice that these do not match. So that tells us that f of x is not odd. So I could say here that f of negative x is not equal to negative f of x. So the conclusion that we could draw from this, we could say, therefore, f of x is not odd, okay? Or I could say is not an odd function. So this is the more technical way of writing it out, but once again, you could get away with using this argument over here. You just have to be very careful how you write the sentence. So now we're moving on to the part 3 questions. There's 4 questions here, and each one is worth 4 credits. So we have to solve this system of equations algebraically for x, y, and z. So what I'm going to do first is I'm just going to label this one here equation 1, equation 2, and equation 3. That way, when I make my manipulations to some of them, it's just easier to label. So if I have to solve this algebraically, I'm going to use elimination here, and I'm going to look for equations that wipe each other out nicely. So the ones that are jumping out at me are equations 1 and 3. If I multiply equation 1 by 2, this is going to give me, I'm going to have 6x, so I'm just doubling everything, and then minus 2 times 8y is 16y, and then 2 times 2z is 4z, and now I could set this equal to 2 times negative 60 is negative 120. So here's 2 times equation 1, and then underneath, I'm going to write equation 3. So equation 3, I have negative 6x, I have plus 2y, and I have minus 4z. So this one, and I just write down the constant here, 36, is nice to eliminate right away because when I add 6x plus negative 6x cancels, and then 4z plus negative 4z also cancels. So right away, I get 2 variables canceling, and this gives us negative 14y equals. And now the difference of these two here is going to give us negative 20 plus 36 is minus 84. So now I just divide both sides by negative 14. And this is going to give us, we're going to have y is equal to 6. So this is one of the variables solved for. So now this is going to be useful when I have to solve for one of the other variables. But now maybe I'll make use of equation 1 and equation 2. So for this one, I could use these two, but then, you know what, looking now, I would have to multiply both equations by a number each to get variables to match and cancel. So maybe instead of doing equation 1 and 3, let me try equation 2 and 3. So looking at this one, okay, how about we eliminate x? So this time I'm going to multiply equation 2 by 3, and I'll leave equation 3 alone. So I'll do 3 times equation 2, and equation 3 is going to get left alone. So I'll just make that a little bit neater. So equation 3, we're going to leave it alone. So 3 times this one, I have 3 times 2x is 6x. 3 times negative 7y is negative 21y. And then 3 times negative 5z is going to give us negative 15z. And this, I'll just clean this up, is equal to, if I multiply this by 3, I get negative 93. So I'll just make a little space here so we can fit these side by side. So now equation 3, I'm just going to rewrite. We have negative 6x. We have plus 2y, and we have minus 4z is equal to, and we have 36. So these I will add together, and then this time I get 6x minus 6x canceling. Negative 21y plus 2y is negative 19y, and then I have negative 15z minus 4z is minus 19z, and this is equal to, if I subtract these two here, So let's just see. These are going to be 57 away, but negative, so minus 57 I get here. And now we already found that y is equal to 6, so that we could now plug in. And I'm just going to move this over a little bit so that it stays nice within the boundary here. So now next I'm going to plug in y equals 6. We have negative 19 times 6, and then minus 19z. And this is equal to, we have negative 57. So we could work out this product. This is going to be negative 114, and then we have minus 19z is equal to negative 57. So then from here to solve for z, we could just add 114 to both sides. And from here, we have these terms canceling out. Now we have negative 19z equals, and if I do 114 minus 57, I get 57. So then I just divide both sides by negative 19, and this tells us that z is equal to, we have negative 3. So now we can move on to find the last variable. And for this, we could pick any one of these equations and plug in for y and z, and that'll tell us what x is. So let's say I take equation 1. So equation 1, now I'm going to plug in, I have 3x, and then I have minus 8 times y is equal to 6, and then I have plus 2 times z is equal to negative 3. And this is now equal to, we have negative 60. So now I just solve this equation. So we have 3x, we have minus 48, minus 6 equals, and we have negative 60. And now this gives us 3x minus 54 equals negative 60. So this now is just a simple two-step equation. So we're going to solve by just adding 54 to both sides. So we do plus 54. And we're going to have on the left, these terms cancel. 3x equals negative 60 plus 54 is negative 6. Divide both sides by 3, and we get our last variable here. We have x is equal to negative 2. So here are the values for x, y, and z. Now, one more thing before we move on. We can't do this for full credit, but this is a nice option if your calculator could do this. So we go to apps, and then number 9 is polynomial simultaneous. So I'm going to do simultaneous equation solver. So that's option 2. And we have we have 3 equations here. So I'm going to press 3, enter, and then I'm going to go down, go up to 3, and hit enter. So we have 3 equations and 3 unknown variables. And now I'm going to press graph to go next. And then I just type this in. I have 3x and plus negative 8y, or I could press subtract and then 8, and then I press enter to make 8y. So you could do plus negative or just subtract, whatever makes you happier. And then I press enter to go after this and press 2, enter, and then I have 2z is now equal to, and then negative 60. I press enter. So I'm just typing this in manually here. I have 2x, and then subtract 7y. So 7, enter. You have to press enter a lot here. And then minus 5z. And this is equal to negative 31. And I'll do this one more time. For the last equation, I have negative 6. This time I have to use the negative. So negative 6x plus 2y. And then we have minus 4z equals 36. And then I just press graph to solve this. And notice I get x is negative 2. I get y is equal to 6. And I get z is equal to negative 3. So I get all the values that I had by doing this algebraically. So this makes me confident for sure in our answer. But just know this may or may not be an option. But the calculator is like a pretty magical tool for the test. So if you are allowed to do this, it's at the very least just awesome for checking your work. Question 34, in the town of Skaneateles, and I promise that is how you pronounce it, New York, house prices since 2008 have changed based on the function h of t, where t is the number of years since 2008 and h of t is the median house price. Determine the average rate of change for the median house price in Skaneateles from 2010 to 2018 to the nearest dollar per year. And we have to explain what this rate of change means as it relates to median house prices. So for this one here, a sneaky detail to look out for is that t is the number of years since 2008. So if we're going from 2010 to 2018, 2010 is 2 years since 2008. So that would be t equals 2. And then 2018 would be 10 years since 2008. So that would be t equals 10. So in terms of finding the average rate of change, we're going to do h of 10 and then minus h of 2 divided by, and then we're doing 10 minus 2. Okay, and then the units here are going to be dollars per year at the end. So let's go over to the y equals, and we're going to type in the function for h of t. So we have 200,000 And then we have in parentheses here 1.045. And we're raising this to the t power, but we'll use x. So a nice little trick we could do is we could go over to the table, and yes, we could copy down the values here for 2 and 10 like this. So if we want, once again, we could just go here and we can copy down these values. That is one way to do this. But another cool way to do this is to go to the main screen after we have the function typed in y equals and press alpha y equals enter to pull up a blank fraction. And when I want to write h of 10 minus h of 2, what I could do is I could press alpha trace and then y1 because I saved the function h of t in y1, and then I just have to put parentheses 10 and close it. And that will tell the calculator to find h of 10. And then I could press minus. And if you don't have one of these newer calculators, you could always press vars. You go to the right, you go to function, and you go to y1, and you could access y1 this way. And then I put parentheses 2 and I close it. So this is going to take h of 10, h of 2, and subtract them. And then we're going to divide by 10 minus 2. We'll pretend we don't know 10 minus 2 is 8. We press enter, and it gives us the value that we need. Now, they told us to round to the nearest dollar per year. So we go to the ones place, and to the right is a 6. So we're going to round this up to 11,524. So we have 11,524. And we don't actually have to write the units in here like this. We can, though, if we want to write. They told us that the units at the end are going to be dollars per year. So I could just say dollars per year off to the side like this. So dollars and then per year. So this would give us the full credit for the first part of the question. Now, for the next part of the question here, we have to explain what this rate of change means as it relates to median house prices. Well, if you think about this, we can go to the graph and notice nothing is showing up, and that's because we're talking about home prices. And notice that up to 10, the home price goes up to 310,594-ish. So what I could do is I could adjust my window to go up to, let's say, 400,000. So I'm going to go way up here. And now we get a pretty nice view of the graph. And I'm going to change my window to go from, let's say, 0 to 10. And what we found was the average rate of change from t equals 2 to t equals 10. So what this average rate of change tells us is that the price of homes is increasing. Okay, the median price of homes is increasing in Skinny Atlas from t equals 2 to t equals 10, or I could say from 2010 to 2018. And the rate that the median price is increasing is $11,524 per year. Now, one thing I want to point out about this explanation, it's very important that you include the interval where this average rate of change is taking place. If you do not mention that this is occurring from 2010 to 2018, you will lose a point for this part. Okay, so just please make sure that you are mentioning the time frame here, but this response will get us full credit. Question 35, a sporting goods manufacturer is trying to determine if they should continue to produce multiple types of hockey pucks. The company surveyed 50 randomly chosen customers and asked them if they purchased both game regulation pucks and lighter training pucks. Of those surveyed, 40 of them said that they purchased both types of pucks. A simulation that was run 100 times based on the survey results produced the approximately normal results below. And what we want to do first, there's two parts here, but first for part A, we have to determine an interval containing the middle 95% of plausible values that estimate the proportion of all customers who would purchase both types of pucks from the company. So anytime you hear the phrase the middle 95%, what you're going to be doing here is you're going to be doing the mean plus or minus 2 standard deviations. Okay, so this tells you to do the mean, and then you're doing plus or minus 2 standard deviations. So what we're going to do here is we're going to take the average 0.795 and we're doing plus or minus 2 standard deviations, and the standard deviation here is 0.085, and this is going to help us build the interval. So we could just type this in on the main screen. We're going to have 0.795 and we're adding 2 times 0.085, and we also have to do minus 2 standard deviations. So I'm just going to press enter on the previous line and scroll over to the plus and make it a minus. And now this is going to give us the beginning and end of our interval. So now I'll just write down the interval. We're going from 0.625 to 0.965. Okay, so we're just going to write down both of these decimal values here and make sure to separate them with a comma, and this will get us credit for the first part. Part B, the company will continue to manufacture both types of hockey pucks if it is reasonable to assume that the true proportion of customers who buy both types of hockey pucks is above 0.60. So using the interval from part A, we have to explain whether or not the company should continue to produce both types of hockey pucks. So this part here is definitely a little bit tricky, especially this part over here. If it's reasonable to assume that the true proportions, let me highlight this. So we're looking to see if the true proportion of customers who buy both types of hockey pucks is above 0.60. So here, what we're going to do using part A is we have to think, is the true proportion above 0.60? Is this reasonable to assume this? Well, if we look at the middle 95%, you could see that if we're talking about the middle 95%, and that's going from 0.625 all the way out to 0.965. So I'm not necessarily drawing this to scale. This is just to help us imagine what's going on. So the middle 95% is here, and they're saying, is it reasonable to assume that the true proportion is above 0.60? So 0.60, let's say, is over here. We'll just call that 0.600. Well, notice that the middle 95% is greater than 0.600. Okay, it is above. So notice here, this explanation uses the middle 95% interval from part A. So that is referenced. And since that interval is entirely above 0.60, the company should continue to produce both types of hockey pucks. Question 36. First, we have to graph y equals f of x on the set of axes below. So we're going to go over to the y equals, and we could type in f of x. And to get a custom log with a base of 2, we're going to press math. We're going to hit the up arrow. And notice here at option A, there's log base. So we go here, we press enter, and now we could just write in 2 for the base. We hit the right arrow to go inside the log, and we press x minus 1. And then we hit the right arrow to get out and press r plus 3 at the end. And we could press graph here. And what you'll notice is that the graph seems to stop at this location, but that's not quite what's happening here. If we press second graph and go to the table, notice that the table here has an error when x is 0 and x is 1. And then once we get to x equals 2, we could actually see that we're getting some values here. So we're going to borrow these values here to get our graph going. Now, if I'm putting together a table here, I'm only going to write down the values that have integer coordinates. So I'm going to write down 2, 3. This is a good point to plot. 3, 4. I'm going to skip 4, 4.585 because unless you bring a magnifying glass to the test, that's going to be really hard to plot. So just skip this one and graph 5, 5 next. And then you could graph 9, 6. So these are the most reasonable points to plot. So now we could just connect these points here, and this is our graph of y equals f of x. No, this is a very dangerous bear trap, okay? Just please make sure that you're not stopping here. You do have to say a little bit more. So the calculator did get cut off, but what's really going on here is we have a vertical asymptote at x equals 1. So the graph did appear to get chopped, but that's because these calculators aren't perfect. You have to be able to fill in the rest. So what's really going on is that we have a vertical asymptote at x equals 1. So the graph is going to go on forever, but it's just going to drop down like this. Okay, so you could put an arrow like this to indicate that the graph is approaching this vertical asymptote here. And I would even sketch this in just to, show that you're approaching this value here at x equals 1. And then what we have is we could label this function here as the function f of x. If you want to continue the vertical asymptote all the way to the end of the graph, that's fine, but just know that this is a very sneaky detail that I've seen a lot of students mix up. And if you want to know how do we get that vertical asymptote, let's say without the calculator, the key is this part inside here. The domain of f of x, this is not part of the question, but if I had to find the domain, the inside of a log has to be positive. So this tells us that x minus 1 has to be greater than 0, which if I just add 1 to both sides, this tells us that x has to be greater than 1. Which is why when you had values that were less than or equal to 1, the y value shows up as an error. So what that tells us, though, if x has to be greater than 1, then the graph is going to be approaching the line x equals 1, but it'll never actually go through it. Okay, so this is just a nice way of finding the vertical asymptote of a log function. The math that I do in my head is I basically set the inside, the linear part on the inside, equal to 0, and that tells us the equation of the vertical asymptote. So the equation of the vertical asymptote for f of x is going to be x equals 1. So now for the next part, when f of x is reflected over the line y equals x, a new function is formed, g of x, and we have this exponential function here. And we have to state the equation of the asymptote of g of x. So if I'm doing this without a calculator, if f of x is reflected over the line y equals x to get g of x, that tells us that g of x, this is the inverse of f of x. And you don't actually have to write this down to get the credit, but this is just conceptually what's going on, that this function is the inverse of f of x. And remember the technique for finding an inverse. You switch the x and the y. So a little trick here, I know that if I just have to switch the x and the y, then the asymptote equation is just going to be, instead of x equals 1, it's going to be y equals 1. And you could even see here that if I reflected the vertical asymptote over the line y equals x, I would get the horizontal line y equals 1 like this. You could see here that if I drew in y equals x like this, that it's going to be the mirror line for these two asymptotes. So I don't actually have to draw g of x or its asymptote on the graph. I have the option to do that, but that's just a tool to help us see what the actual asymptote is. Or we could just graph g of x. So let's type in g of x. We have 2 to the power x minus 3, and then we get out of the exponent, hitting the right arrow, and we write plus 1. And now I'm going to also graph the horizontal asymptote y equals 1. And notice we have the graph in blue and we have the horizontal asymptote in red. Now, if you're not convinced that this is the horizontal asymptote, you could go to the table, press second graph, and if we scroll back like this, all the way back, we could see that as we move farther to the left, we're getting y values that are getting closer and closer to y equals 1. Okay, and as we move away, back towards 0 and the positives in the x direction, our y values increase. But if we just kept going back, the calculator would eventually run out of energy here. And let me go over to the x just so we could see that, I could keep scrolling back like this, and then eventually we're going to run out of zeros and it will probably just round it. But the idea is that these zeros would just keep going out more and more until we get to our non-zeros. So y equals 1 is definitely the equation of the asymptote of g of x. So now moving on to the part 4 question, the final boss, and this question is worth 6 credits. Question 37, Megan is performing an experiment in a lab where the air temperature is a constant 73 degrees Fahrenheit and the liquid is 237 degrees Fahrenheit. 1.5 hours later, the temperature of the liquid is 112 degrees Fahrenheit. Newton's law of cooling states that, and we have this equation here, and then we define all the variables here. And we need to determine the value of k to the nearest thousandth for this liquid. So for this one, we're just going to go piece by piece and see what each piece means that they gave us. So they told us the air temperature is a constant 73 degrees Fahrenheit. So the air temperature is a constant 73 degrees Fahrenheit. And the air temperature is T sub A. So we're going to say T sub A is equal to 73 degrees Fahrenheit. So I'm just going to define all the variables in the question, and then I'm going to plug it into the Newton's law of cooling formula. So then next we have the liquid is 237 degrees Fahrenheit. So that's going to be the initial temperature of the liquid. So that's T sub naught over here, or T naught, or T sub 0, whatever you want to call it. So we have this is equal to 237 degrees Fahrenheit. And I know that this is the initial temperature because then they tell us 1.5 hours later, the temperature of the liquid is 112 degrees Fahrenheit. So the temperature of the liquid at the time t is the next piece that we need, okay? And if t is being measured in hours, see it's t hours over here. So t is equal to 1.5 is 1.5. And then that would tell us the function value over here. We're doing t at 1.5 is equal to 112 degrees Fahrenheit. Okay, so these are all the values that we need. And now we could plug them into the formula to solve for the value of k. So we're going to have t of t, or in this case, t of 1.5 is equal to 112. And I'll leave the units out here since we're solving for the value of the constant k, is equal to t sub a is 73, plus, and then we have t naught minus ta. So t naught is 237, minus TA. I'll just make that a little neater. So minus TA is 73. And we're multiplying that by e to the negative k times lowercase t is 1.5. Okay, so there's a lot going on here, but now we just have to simplify things a bit. So for this part, we could just subtract. So we do 237 minus 73 is 164. Okay, so this is going to give us 164 times e to the negative 1.5k, I'm going to write. And then we have 73 plus over here like this, and this is equal to 112. So now we could start the algebra part. We're going to go minus 73 on both sides, and that's going to get rid of the constant over here. And when we subtract, we're going to get 39 equals, and we have 164 times e to the negative 1.5k. And from here, we want to solve for k, so we're going to divide both sides by 164. So we'll do this next, and 164 over 164 cancels, and we're going to have 39 over 164 is equal to, and then we have e to the negative 1.5 times k. And then from here, I'm going to take the natural log of both sides. Okay, so natural log of the left and natural log of the right. Natural log and e are opposites, so they just cancel. And then this gives us, we're going to have natural log of 39 over 164 is equal to, we have negative 1.5 times k. So to solve for k, just divide both sides by negative 1.5. And now to solve for the actual value of k, we're just going to use the calculator. So we could go to the main screen here, and we'll press alpha y equals enter to pull up a blank fraction. And we have natural log is over here next to 4. And we've got 39 divided by 164. We close the parentheses and we go to the denominator, and we're dividing by negative 1.5. And this gives us the value we need. So we're rounding to the nearest thousandth. So we go 3 places after the decimal is a 7. To the right is a 5. So we're going to round this up to 0.958. And here is the value of k that we need. Question 37, continue, determine the temperature of the liquid using your value for k to the nearest degree after 2.5 hours. So I just wrote down the formula from the first page. So now what we could do is we could define t of t with an explicit formula, because now we have a value for k. So t sub a, we had 73 plus, and when we did t naught minus ta, that was 237 minus 73. That was 164. And now this gets multiplied by e to the negative k. And k we had 0.958 after we rounded, okay? And they said to use the value for k that we found in the previous part. And then we're multiplying this by t. So here's the function t of t. So if we want to find the temperature after 2.5 hours, that's at t equals 2.5. So we have t of 2.5 is equal to, and we have 73 plus 164 times e to the negative 0.958. And we're going to multiply this by, we're going to have 2.5. Okay, so this is what we're plugging in here for t. So to find this value, what I want to do first is go to the y equals, and I want to write in our equation for t of t. So we have 73 plus 164, and then we have times e is second natural log to the negative 0.958 times t, but I'm going to put x in place. And now I go back to the main screen, and I could use that shortcut again. I could do alpha trace y1, and that's going to pull up the function for t of t, and we're plugging in 2.5. So we do this, and ultimately we are rounding to the nearest degree. So this is going to help us get the value here. If you'd rather do this a different way, you could press second window and change the table, the independent variable from auto to ask. We press enter, we press second graph, and then we type in 2.5 like this. And we go up here to the value for y1, and we get this long decimal. So either way, we get the same answer. So I'll just write out a few decimal places here. We have t of 2.5 is equal to, and this works out to 87.952 if I round out to 3 decimal places. But if we're going to round our final answer to the nearest degree, I'm just going to say 88 degrees Fahrenheit. So here is our solution to the second part. And now for the last part of this question. Megan needs the temperature of the liquid to be 80 degrees Fahrenheit to perform the next step in her experiment. Use your value for k to determine to the nearest tenth of an hour how much time she must wait since she first began the experiment. So in this equation, t of t is the current temperature of the liquid. So we want t of t to be equal to 80, and we need to find out when does this happen, at what time. So we could say 80 equals, and we have 73 plus 164 times e to the negative 0.958 times t. And from here, all we need to do is determine to the nearest tenth of an hour how much time it takes. They didn't say to do this algebraically, so we can use a calculator here. So let's go over to the y equals, and we already have t of t written in the y1 spot. So we could just type in 80 in the y2 spot to see when does t of t reach a value of 80. And we press graph, and oh no, we can't see anything. And that's because the y maximum is stopped here at 10. If we need to see when the graph goes up to a height of 80, maybe we could just bump this up to 100 and see where the graphs intersect. And notice there's our intersection point right here. So we're going to press second trace number 5, and that's for intersection. And we just scroll until we're really close, and then we press enter 3 times. And this tells us when the temperature of the liquid reaches 80. So now to show your work, what you could do is just provide a rough sketch of what you just did. So I could say that this is t of t, and this is the line y equals 80. Okay, so this is the line y equals 80. And the intersection point, I would just write down the intersection point here is at 3.29, and then 22299, comma 80. And then just make a comment here. You could say that you trace the intersection point. Okay, so I would just say that, oh, I traced the intersection point. So I traced the intersection point. And if we really want to play it safe, we could say t of t and y equals 80. We could say exactly what we typed in the calculator. So from here, now we just have to record our answers. So when to the nearest tenth of an hour does the temperature of the liquid reach 80 degrees Fahrenheit? Well, if we look here, in the tenths place is a 2, to the right is a 9. So we could say at 3.3 hours. Okay, so 3.3 hours is the solution to the last part.